Welcome to the L4S demo. So what we're showing here is the Broadband Forum work on WT519. So that's a piece of work looking at how to apply L4S to a broadband network. So all our end users are getting increasingly aware of how important latency is. L4S is an IETF technology designed to reduce latency through queuing delays. It does that by the network and the application working together, communicating with each other in order to ensure that queues don't build in the network, and therefore end users get a much lower and more stable latency. So if we look over at the screen over here, what we're showing here, what we've got on a live demo, is an application server, a broadband network gateway with a queuing point, a home router with a queuing point, and each of these queuing points have L4S active queue management enabled on them. And then we are running traffic from the Wi-Fi down from the application server to both the Wi-Fi device and from the application server to the wired devices. And we're congesting both of these congestion points. Now, these may or may not normally be congested all the time in normal broadband usage, but when customers are using all of their broadband line, these are often the bottleneck links in the path from the internet down to an end user's home. So we've got the traffic load here at the bottom. So we have traditional classical internet traffic, which is we've got 5 streams running here. And then we've got the L4S traffic running at the same time, and we've got 3 streams running there, both to the Wi-Fi device and the wired device. And the important part to note here is the latency difference. So for the classical internet traffic, we have here showing the latency, and we can see the latency is varying quite a lot as the queues build and empty. And then we have showing on the right here the latency for the wired device for L4S, which is showing a very, very stable 20 milliseconds plus 0.9 of a milliseconds in round trip delay. An important point to note in the demo is that we've added 20 milliseconds of base latency between the home and the application server in order to best represent a normal internet line. So in reality, the L4S traffic here, the queuing delays are 0.7 milliseconds in round trip. On the Wi-Fi, it's a little bit more varied, but we've still got a very, very low variation in the latency, and we're keeping that very, very tight compared to the classic traffic, which has shown variation slightly higher than on the fixed, basically due to the Wi-Fi environment, and especially the Wi-Fi environment in an exhibition like this. And we're seeing the variation probably greater than the fixed line, but still the Wi-Fi L4S rate is very, very stable, and the latency is kept low.
Hi, I'm Andrew Dignan from Intel. I'm going to talk through the hardware setup for this demo. Here we have our application server streaming TCP traffic with an iPerf traffic generator. This is an Intel server sending to a BNG software stack running on top of an Intel server here, which then transmits to the Nokia wireless access point, which has a wired connection to this Intel client device and also to the laptop here over the Wi-Fi connection. So in this part of the demo here, we're showing the scaled up performance. So this is running on a Xeon CPU. On one single core, we have 100 subscribers and there's 7 gigabytes per second of traffic, about 3.5 for the L4S traffic and 3.5 for the classic traffic. And we can see the round trip latency delay for the L4S traffic is about 20 milliseconds, and for the classic traffic, it's averaging at 35 milliseconds. So with the congested traffic, the L4S traffic is showing much lower latency at scale. And this is on one CPU core, so this can be scaled in principle as CPU cores and memory allow to multiple cores on an Intel Xeon server. So we have integrated the L4S into our hierarchical quality of server, which gives fine-grained traffic shaping, and we have multi-level QoS. We have the L4S queue and the classic queue, so it's simplified into 2 queues instead of previously we would have had, for example, 4 queues. So it enables fine-grained traffic shaping per subscriber across the broadband BNG network.
So the use cases for L4S are quite wide, but generally very applicable to any interactive application that end users are looking for. Good examples of those would be cloud gaming, video conferencing, streaming virtual reality, and a number of industrial applications. So there's a huge opportunity here and a huge appetite for the deployment of L4S in networks. So L4S is seeing quite a lot of adoption in the industry. There's a number of major application vendors that are implemented or have implemented L4S into their applications. And what we're seeing now is the greater interest in how we can deploy that into broadband networks. So that's what the work of the Broadband Forum is doing, looking at the enablement of L4S in broadband networks and how it will interact with the applications across the home, the access, the BNG, and up into the core. Anyone that's in the industry that's interested in coming in and getting involved in this work, then please come and speak to the Broadband Forum.